Potential hurricane impacts on Point Pleasant Park, presented by Isabel Andrews, Sarah Campbell, and Jessica Hickey. Point Pleasant Park is a significant urban park in Halifax, Nova Scotia, with deep cultural meaning to the Mi'kmaq population. As part of their traditional territory, Mi'kma'ki, it has been culturally, spiritually, and ecologically important for generations. Beyond its role as a recreational space, the park supports local ecosystems and biodiversity. It is home to a mix of Acadian forest species, a blend of northern hardwoods and boreal conifers that are naturally resistant to disturbances. In 2003, Hurricane Juan severely damaged the park's forest, toppling thousands of trees and reshaping the landscape. This event created a unique opportunity to study forest recovery in an urban setting. Since then, the park has served as a living laboratory to observe ecological recession and how ecosystems naturally recover from disturbances. However, urban influences such as human activity add complexity to this process. This research provides valuable insights into forest resilience and the impact of urban environments on natural recovery.
In this study, 6 sites at Point Pleasant Park were chosen to be surveyed. These specific sites were selected because they had the highest hurricane impact on the forest structure. Each study site was 20 meters by 20 meters, and within all the sites, all living trees that had a DBH, which is the diameter at breast height measurement, greater than or equal to 2.5 centimeters were identified, and those were the trees used for the data collection. The data that was collected each year was the tree density size per species per site, as well as the tree size in centimeters for each tree per site. This measurement was taken at the DBH, which was 4.5 feet above ground level.
To assess overall long-term changes in the forest community, total tree density was measured in Point Pleasant Park from 2003 to 2024 and was analyzed using a linear regression model as seen in Figure 3. The results indicate a positive correlation with an R-squared value of 0.49, suggesting that nearly half of the variation in total density is influenced by shifts over time. While this R-squared value indicates time having a moderate impact, the regression analysis yielded a highly significant p-value, providing strong evidence of a consistent pattern over time. Using the regression equation, where x represents the year, estimated tree densities for 2004 and 2024 are negative 11.114 and positive 224.036, respectively. This pronounced increase in density highlights the forest's post-disturbance recovery following Hurricane Juan. By analyzing tree density as an indicator of changes in the forest community, the significant results shown in Figure 3 lead us to reject the null hypothesis, which suggested no change in total density following the hurricane. These findings align with those of Sharma et al. In 2021, who reported a significant increase in seedling and sapling density after a hurricane. Similarly, Burley et al. 2008 found that hurricane disturbances did not negatively affect seedling regeneration. Torchin 2016, in their study of post-hurricane succession in Point Pleasant Park, also observed the forest recovery and the increase in tree density following hurricane events, further supporting the notion of a positive post-disturbance trend. Together, these studies provide strong evidence of a significant increase in forest density in the years following Hurricane Juan. Based on this trend, I anticipate that as the forest progresses towards its climax community, the tree density will continue to rise until it ultimately stabilizes at levels similar to those observed before the hurricane. This forecast aligns with Laurel et al. 2019, who found that 20 years after a storm, stem density had returned to pre-storm levels.
Figure 2a represents the density of red maple trees at Point Pleasant Park from 2004 to 2024, using linear regression analysis to demonstrate the impact of Hurricane Juan on tree density. Figure 2b represents the density of red spruce trees at Point Pleasant Park from 2004 to 2024, using linear regression analysis to demonstrate the impact of Hurricane Juan on tree density. The data from 2004 to 2024 reveals significant shifts in the dominant species within the forest. In 2004, red maple trees were absent, while red spruce had an average density of 3.25 per 400 meters squared. However, by 2024, red maple trees had experienced substantial growth, reaching an average of 31.6 per 400 meters squared. In contrast, red spruce trees had an average of only 8.8 per 400 meters squared in 2024. Since there was a big change in density between 2004 and 2024, we will reject both null hypotheses. For red maple trees, 15% of the variation in density over time can be attributed to time-related changes, while for red spruce, only 12% of the density variation is explained by these time-related factors, so both have minimal relation. Why did these changes happen? These changes align with findings by Burley et al., suggesting that the forest is in an early successional stage following the hurricane. This stage is characterized by the dominance of pioneer species like red maple trees. Red maples are well suited to tolerate fluctuating soil moisture and light levels, allowing them to persist even after the removal of tree canopies. This adaptability likely explains the observed changes in species density over the 2 decades. As the forest progressed towards its climax community, species composition will continue to evolve. Given that red maple trees are currently dominant, we might expect it to eventually be replaced or outcompeted by species that thrive in more mature forest conditions, like the red spruce trees.
To evaluate the changes in community metrics at Point Pleasant Park, the number of species at each site from 2003 to 2024 were counted to measure the species richness. A linear regression model was used to analyze the data, as shown in Figure 3. The results revealed a positive correlation with an R-squared value of 0.6051, which indicates that over 60% of the variation in species richness can be explained by changes over time. This suggests a consistent trend in species richness throughout the period of this study. These findings lead us to reject the null hypothesis, which proposed no change in species richness following the hurricane. This aligns with the work of Burley et al. 2008, who found that urban forests tend to follow natural successional patterns after major disturbances. In their study, they observed a significant recovery in species composition in the early years following the hurricane, suggesting that the hurricane did not hinder species regeneration. Based on these findings, I expect that species richness will eventually stabilize at similar levels to those observed before the hurricane.
Based on the trends in the data, it appears that the Acadian forest in Point Pleasant Park is currently in the mid-succession stage. The substantial increase in tree density following Hurricane Juan indicates a recovery process, with early successional species gradually being replaced by more established tree species. However, the park's urban environment may influence the progression of this recovery. For example, human disturbances such as foot traffic and ongoing park maintenance could hinder natural regeneration, while limited seed dispersal resulting from urbanization may impede the forest's ability to fully recover. Previous research highlights that urban parks often experience delayed succession due to these factors, as evidenced by Turchin in their study of post-hurricane recovery in Point Pleasant Park. Incorporating traditional knowledge, such as the Mi'kmaq concept of two-eyed seeing, can be valuable in guiding forest management practices. This approach integrates Indigenous and Western scientific perspectives, offering a more holistic understanding of forest dynamics. For example, Mi'kmaq teachings on sustainable land management and respect for natural cycles can inform restoration efforts by emphasizing ecological balance and long-term recovery. This integrated perspective can help develop more efficient management strategies, supporting the recovery of Point Pleasant Park toward a mature Acadian forest. We would like to acknowledge and thank all the ecology students from the years prior to our lab section who took the time to collect these samples, and to the instructors who put together the figures, which enabled us to perform these analyses. We are also aware that this study was conducted on the ancestral and unceded territory of the Mi'kmaq people.